Hello, my name is Rachel Force from the University of New Brunswick, and I will be presenting my honors research on how stable isotope analyses of baleen plates reflects the right whale distribution shift to the Gulf of St. Lawrence. So in the past decade, right whales have shifted their northern summer feeding grounds from the Bay of Fundy to the Gulf of St. Lawrence. And we want to know if this distribution shift is reflected in their seasonal and annual diet by using stable isotope analysis. So stable isotopes within an organism incorporates a fraction of the stable isotopes from their prey, so we can determine what and where that animal was eating. It's just like the saying, you are what you eat. The analysis measures the ratio of the heavy to light isotopes of naturally occurring isotopes, and it is measured in delta notation, which is the relative abundance between the isotope ratio of a sample and of an international standard. This graph depicts how delta 15N and delta 13C are incorporated throughout the food chain, from the primary producers to the copepods and then to the whales themselves. We can then compare the isotope data to isoscapes to estimate where the whales have traveled to. These delta 15N and delta 13C isoscapes were created based on the stable isotope ratios of plankton in these areas. As the whales migrate south during the winter months, their stable isotopes should reflect that movement and be more enriched compared to the summer months when they are in less isotopically enriched waters up north. So I sampled 6 adult right whales, baleen plates. One of the individuals died in 1992 and 5 of them died in 2019. I subsampled every 2 centimeters along the outer edge of the baleen plate and collected the powder for delta 15N and delta 13C analysis. I compared my data to Nadine Lysiak's PhD data, where she performed similar methods on 8 adult right whales between 1992 and 2005. So the total sample size was 13 individuals, 8 of which represent the pre-2010 whales and 5 representing the post-2010 whales. So these are the results from one of the individuals with the delta 13C values in the top graph and the delta 15N values in the bottom graph. Along the x-axis is the distance from the tip of the baleen plate, so that the data points demonstrate the isotopic values of the full baleen plate from the oldest growth to the newest growth. Baleen is made from a metabolically inert tissue, which incorporates the isotope ratios of the whale over the past several years of its life. So it's a useful tool for understanding an individual's feeding behavior and where that individual may have been traveling to in the past 7 or so years before it died. The most prominent pattern in the data is the annual oscillations, especially occurring in the delta 15N values. So each one of those bumps represents 1 year of growth, with the peak occurring in the winter and the valleys occurring in the summer. And using these oscillations, we determine the annual baleen growth rate to be 27 centimeters. So these graphs display the peak and valley data points of each individual over time, where each one of those colors represents one of the 13 individuals. The top 2 graphs are the delta 15N winter and summer values, and the bottom graphs are the delta 13C winter and summer values. The first group of data is the pre-2010 whales, and the second grouping is the post-2010 whales, which tended to have higher isotope ratios. There's more variation between individuals before 2010. After 2010, the individuals showed very similar patterns, especially in the delta 13C winter values. There's also an interesting decreasing trend in the delta 13C values in the whales between 1999 to 2005. So to answer the main research question, I used a linear mixed effects model to determine if time, season, or sex affected the isotopic values the most. In both isotope data sets, seasonality and time significantly influence the data, with seasonality having the largest influence on the nitrogen isotopes and time having the largest influence on the carbon isotopes. The winter values were higher than the summer values, and the post-2010 whales were more enriched in delta 15N and delta 13C compared to the pre-2010 whales. And there's also no significant difference in the isotope values between males and females. So in summary, I found that stable isotope analyses of the baleen plates reflects right whale migration, and the right whale isotope ratios have changed since the range shift to the Gulf of St. Lawrence. But what does this change mean? More work is needed to find out if the isotope change could be due to changes in the right whale's diet, in their stress and fasting patterns, or in the spatial variability in the isotope ratios of their prey. We need a more robust isoscape in the Bay of Fundy and in the Gulf to better represent those areas. So in conclusion, stable isotopes is an important tool for future management efforts because it can be used to predict where the whales have traveled and where they may be going if another distribution shift occurs. I'd like to thank the following people, and thank you for listening to my presentation.